All right, there we go. Number 3 from lesson 8. Lesson 8. So the first step, reference node, which luckily is already given. And that is ground. Reference node just means ground. Pretty much, and there's other times in the course where we'll call something a reference voltage. Things like that, there's always a 0 associated with whatever we're calling reference, right? So the reference node is where voltage is equal to 0. The other 3 that I have right here, I don't know that. I'll call this VA. I don't know that voltage. I do know this voltage, so we'll say voltage at C is equal to 16 volts. And then right here, VB, I don't know that. I'll draw the currents in green just so we can see them a little bit differently. Here's one coming out, one going there. That one's going across is what they already called I unknown. I'm just going to leave it in the direction they drew it to make it most straightforward. And then this one I'll draw down. And this one, I drew it going in. The reason why you might draw it in, if you wanted to draw it, try and draw all of them out. That also can work. Your equation will work at the end. You might draw this way because you know that that's 16 volts going up. And so, you know, if you're imagining current flowing, it probably is flowing that way. So if I'm looking at each of these, I'll just call this one 3 amps because I know it. I'm not even going to label it I1 or anything because I know it's 3 amps. I can see that going across. This one I'll label as I1. This one I'll leave as IU, as I unknown. They already gave it to us. We'll call this one I2, and we'll call this one I3. Now, note that I didn't draw the currents going through this one right here, through that 12 ohm resistor, and that's because it doesn't affect my unknown nodes. I am only drawing the currents at the unknown nodes, and that's in the steps. If you look at the online notes at the top, it says draw currents at unknown voltages or unknown nodes. I know the voltage here is 16 volts inside of there, so I don't need to draw the current going down through that. I don't need a nodal equation at node C. I just need nodal equations at A and B. So the way that I'll write it is I'll say at A, because that's my node. What do I have going in, right? Remember KCL, the sum of the currents in equals sum of the currents out. So what is going into this node? I have I unknown. Coming out of it, I have 3 amps in I1.
So you said we don't need an I4?
Correct.
Like I drew an I4.
You can draw it. Here's I4. You can draw it, but once we do these equations, we'll see it won't even show up. I'll draw I4, and we'll see that because all I need is my KCL at the unknown node.
There's no resistance here.
What's that?
Well, I understand now. That's all.
Yep. So here's at B. So what's going into B? I have I3. I3 is going in. I unknown and I2 is coming out. So far, so good. KCL, what goes in must come out. Just follow your own arrows. Whichever direction you drew, you might have drawn it differently. That's okay. Just follow your arrows when you're putting the in and the out together. So now I'll put each of these over here. I1 is going from VA down to ground, which is 0. So I'll just say VA over 2. I2 is going from VB to ground, which is 0. So we'll say VB over 6. There's the 6 ohms, there's the 2 ohms. I'm just grabbing the ones that I see. I3 is going from 16 volts to VB, which is VC. You could write VC minus VB if you just write 16 minus VB. That's also fine, divided by 7. Note that I left one arrow between these called I unknown. Some people will draw an arrow at each node, which is fine. Just note that then the direction will change, so the terms will change of what's being subtracted, but I left it as 1. It's going from VB to A, and it's going across 4 ohms. So there's all of the currents that are inside of this equation. IU, 3 amps is known, I1, I3, IU, and I2. So now we just plug them in. IU is VB minus VA over 4 equals 3. I'm just going to leave it as 3. If I was dealing with something like milliamps, kilo ohms, millivolts, kilovolts, if I was dealing with stuff like that, I would write them in with their values. But if I'm dealing everything is in volts, amps, and ohms, then I drop the units as I solve it. And then I1 is VA over 2. So now we're looking at, that was at A, right? And I plugged them all in. So now at B, I3, oops, let's do that. 16 minus VB over 7. IU is that same term, VB minus VA over 4. And I2 is VB over 6. If we asked for 2 sets of, if we said, give me the nodal equations, this is the final answer. I have VB and VA are my 2 unknowns. I have 2 equations. This is just algebra. If you want to solve it with linear algebra, you can. If you want to solve it with your calculator, you can. If you want to solve it by hand, you can. But I will say this, and this is recorded, so I guess I won't hear it. On a problem, if we ask you to solve for VB and VA, these are each 8 points out of 20, and solving for the unknowns is 4. Please don't waste your time not solving another problem on an exam to get 4 points solving past here. That's just test taking strategy, and that's life. If the XO tells you to do something on your ship and your department head tells you to do something on your ship, which one do you think you're probably going to do? Probably what the XO said. Maybe not every time, but your department head is the 4 points and the XO is 20 points. So in test taking strategy, take care of the big stuff first and even knock out what the low hanging fruit is first. So if the low hanging fruit is setting all this up because you know the steps, get those points first, right? I got 16 out of 20 points by writing my equations through these steps. The messy math is the last 4 points. So there's a piece of free advice. I'm going to write it now if you have the TI 36X Pro. So the way that you're going to set this up is you're going to use second, and the term is called syssolve. It's right above the tangent button. So if you hit second and you hit the tangent button, it gives you syssolve. And what it does, and then you're going to want to do the 2x2. 2x2 linear equation. EQ linear EQU is what it says. All right, that's what it says on mine. 2x2 linear equations. And what it's going to do is it's going to set up a system for linear algebra to do all the determinate Cramer's rule stuff that the video was talking about. But what you want to do is you want to get everything for a term into parentheses like this. And then you have it as some constant on the end. And then I'll put the second equation, VA plus something, VB equals some other constant. All right, so if I'm taking this first equation and I'm looking for what is VA, I'll treat the left side as positive. So I have minus 1/4, and I pull the other one across, VA plus 2 minus 1/2. You don't even have to solve for that. On your calculator, you can just put minus 1/4 minus 1/2. It'll do the math, so save yourself the time of typing it in, writing it down, just type the whole thing in. VB is 1/4. And then the constant that I left on the right side is 3. Everyone okay with that? See where I did that on this one? So we did the first one. So now the second one, I'm going to, because I have so many terms on the right, I'm going to leave the right as the positive. So what I have here is I'm looking for VA. So I have 1/6, and that's it for VA. No, I'm not, correct me, sorry. That's not 1/6. VA is -1/4. There we go. VA is -1/4. VB with the right has a positive 1/4. It has a positive 1/6. And then I pull the 1/7 from the other side. It's negative 1/7 on the left. I pull it to the right, and it becomes positive 1/7. This 16/7 is left on that side, and I can just type in the fraction, 16/7. 16/7 using that fraction button, which is right above the 7 on the TI-36. If I type that in, it will spit it out. And now given on the calculator, what it says is it calls this X and calls this Y, right? We're just using them. So you have to be consistent. Make sure you set up your VA and VB correctly. Another tip is if this was an exam question, these two equations here would be another couple points. Rearranging it, because then it's just maybe a calculator error if you typed it in wrong. So what it'll spit out is it'll spit out X is equal to, X is VA, and VA is minus 3.1 volts, and Y, it's calling it 2.7 volts. And if you just even want to write X and Y, that's fine, and then box your answers. The main thing that I do want you to take away from this is nodal analysis can be used anywhere within a circuit. So you could use this where you don't know voltages and solve with systems of equations. So on a more complicated circuit, we could just pick two nodes and use those two nodes to solve for their node voltages. And that's an advantage to nodal analysis, is it allows us to analyze a circuit anywhere. I will say the last step on this one said solve for I unknown. So if I was doing that, IU equals VB minus VA over 4. When I do that, I have 2.7 minus negative 3.1 divided by 4, and I get 1.45 amps. So there was the final answer. So that's if you have the TI-36. I can solve it, if y'all want, by hand with lots of substitutions like we did. Does anybody want to see that, or would you rather get to the homework? Because if you don't have a TI-36, then you can't do what I just did. Nope. So then if you don't, you're free to go. I'll see if anybody that's still here does want to see it by hand. I do have all the steps ready. And what I'll probably do is I will upload those so you could see the math steps. But like I said, they get messy with a lot of fractions. You can already see this is a little bit messy. It gets even more so once I start doing the math by hand.